Wanted to do an example of finding the force between two charges. And so I'm going to pick two charges. I'll make one of them a negative charge. I'll make the other one a positive charge. And I'm going to give them a value. I'll give this one negative 3 microcoulombs. And I'll give this one positive 6 microcoulombs. And I got to give them a separation too. I'll make them separated by 10 centimeters. So what's going to happen here? Well, since I know that they're opposite charges, they're going to have to attract each other. So they're both going to experience a force, and I'll draw the force in green. They're both going to experience an attractive force. Now, how big is that force going to be? So I'm going to calculate that. And that goes like this. The size that either one is going to feel, I'll call this one charge 1, and I'll call this one charge 2. And the force that either charge 1 or charge 2 feels is going to be equal to K, Q1, Q2, divided by R squared. And as we talked about, this is known as Coulomb's law. It tells the force between two charges. I'm going to put absolute values around Q1 and Q2 because the direction I determine without knowing whether they're positive or negative in the equation, I determine the direction by looking at the situation and saying, well, if they're oppositely charged, they're going to attract each other, and then the arrow that I draw defines the direction of the force that the charge feels. So the red one is going to experience a force to the left, the black one is going to experience a force to the right. Now the size of that force, it's going to be the same size for both charges. K is 9 times 10 to the 9th, that's the units of K. And the K has units of, that's the size of K. And the units of K are Newton, meter squared per Coulomb squared. But when I multiply that times the two charges, I have the absolute value of negative 3 microcoulombs is 3 times 10 to the minus 6 coulombs. And the absolute value of 6 microcoulombs is 6 times 10 to the minus 6 coulombs. I'm not putting in the units here, just to keep it less cluttered, but this would have units. I'll write them to the side. After I'm done, I'll write them just so you know what they are. Divide that by the distance between them squared. Now I want the distance in meters. A centimeter is 1/100th of a meter, so 10 centimeters is 1/10 of a meter. So I want to take 0.1 meters, and I want to square it. And that's how I'm going to solve the problem for finding the force that each charge experiences. It's that equation. And if I put the units in here, this would be meters, that would be coulombs, that would be coulombs, and that would be newtons. Erase that. Newton meter squared per Coulomb squared is what the 9 times 10 to the 9th corresponds to. So those are all the units. So now let me do the math. I have 9 times 3 times 6, so I've got to do that math. And I think that's going to come out to be 162. And I have to also take care of the exponents. I have times 10 to the 9th, times 10 to the minus 6th, times 10 to the minus 6th. So the product of those is going to be times 10 to the minus 3rd. I'm going to write my answer in black, so this is going to be 162 times 10 to the minus 3rd divided by 0.1 squared is 0.01. And so what that's going to do is this is going to make that 2 bigger in the exponent there. So it's going to be 162 times 10 to the minus 1, and the overall units in the end is going to be newtons. So that result is then going to be 16.2 newtons, which is a pretty impressive force when you think about it. That's a pretty darn big force between these two charges that are separated by 10 centimeters. And it's going to be an attractive force. That means that the red charge is going to experience a force of negative 16.2 newtons because it's to the left, I'll say to the left right now. I'll talk about how we deal with the direction shortly. I'll just write to the left. Because it's attracted to the black charge here. And the black charge experiences a force of 16.2 newtons to the right. Alright, so that is this problem. And we'll be doing other ones similar to it, but I'll be changing different things.